Hello students, how are you? Today let us see a few NCERT Exemplar questions on GOC. In GOC, the important topics are nomenclature and the electronegativity of different types of carbon atoms present in the organic molecules and electron displacement effects. Based on this, let us see a few questions. Students, these will be very useful for all the entrance examinations. Now, let us see the first one. In which of the following the carbon marked is more electronegative? The electronegativity of different carbon atoms depends on the hybridization of the carbon. In this, in A, the carbon marked is sp3 hybrid carbon. It is sp3 hybrid carbon. And in the second one, it is double bonded carbon. So it is sp2 carbon. sp2. And in C, it is triple bonded carbon. It is sp carbon. And in the D option, double bonded carbon, so it is also sp2 carbon. We will see different types of hybridizations in organic molecules. Which carbon is most electronegative? The carbon with highest S character. The carbon with highest S character means it is sp carbon. In sp carbon, the percentage of S character on sp carbon is 50%. One S orbital, one p orbital. So it is 50%. So the sp carbon is more electronegative. sp carbon means which is triple bonded carbon. sp carbon forms a triple bond in organic molecules. So in these options, in the C option, this carbon is sp hybridized carbon. So this is the most electronegative carbon among all these options. Okay students, so C is the answer for this. Next, in which of the following carbon marked is most electropositive? Most electropositive. Here it is most electronegative, it is most electropositive. Electropositive nature in these options is dependent on the heteroatom present. What are the heteroatoms? Chlorine, bromine, here also chlorine, and here no heteroatoms. So this is not the option. And among A, B and C, which heteroatom is more electronegative? Among chlorine and bromine, chlorine is more electronegative. So when most electronegative atom is present in the molecule, the electron density moves towards the most electronegative atom. So this carbon, the last carbon, will be most electropositive. And you can observe in A and C, chlorine and bromine are present. Chlorine is most electronegative. So this is not correct. And among A and B, here chlorine is directly attached to the carbon, and in this is a Grignard reagent. Chlorine is not directly attached to the carbon. In the middle, magnesium is present. So electron density will not move towards the chlorine in option B. So this is not the most electropositive carbon. So option A is the correct one, in which chlorine is directly attached to the carbon atoms and the electron density moves towards the chlorine. So option A is the correct answer for this second question. Okay students, next question. Which of the following carboxylate ion is most stable? Carboxylate ion. In carboxylate ion, the negative charge in whichever molecule the negative charge is dispersed, that will be more stable. In this is simple carboxylate ion, and this is alpha chlorocarboxylate, alpha fluorocarboxylate, and alpha difluorocarboxylate ion. These are the different options. In this, halogens are present on the alpha carbon. If halogens are present on the alpha carbon, that will be more stabilized because these are electronegative. The electron density moves towards the electronegative atoms. Now, in this, chlorine, fluorine and 2 fluorine atoms. Fluorine is most electronegative, we know that. So, among fluorine and chlorine, fluorine will dominate. So, this is not the correct option. And here, no halogens are present. So, this is not the correct option. And in this, 1 fluorine atom is present on the alpha carbon and here 2 fluorine atoms are present. So, this electron density moves strongly towards the alpha carbon in D. So, it will be more stabilized. So, option D is the correct answer for this question. Okay, students? Now, the compound which is not reactive towards electrophilic substitution reactions. Reactivity of benzene towards the electrophilic substitution reactions depends on the substituent present on the benzene ring. In these options, nitrobenzene, nitro group and aniline group, amine group, and in phenol OH group is present, and in N-acetyl aniline acetyl group is present on the nitrogen of aniline group. Nitro group is an electron withdrawing group and it is a very strong ring deactivating group. So, nitrobenzene is the correct option. And in this, aniline, NH2 and OH, they are electron donating groups. They are strong electron donating groups, so they will activate the benzene ring. And what is the order of reactivity of these 4 groups? It is not asked in the question, but this nitrobenzene is least reactive, and among aniline and phenol, this phenol is strong activating group than aniline because the electronegativity of oxygen is greater and there are 2 lone pairs present on the oxygen of phenol, and one in aniline only 1 pair is present, 1 lone pair is present, and in N-acetyl aniline the lone pair, the electron donating capacity decreases due to the presence of acetyl group. So, the correct order is C greater than B, greater than D, greater than A. The reactivity towards the electrophilic substitution reactions is in this order among this. This is not asked in the question, but this is the answer. Okay, students? Now let us see one more question, students, based on the RS configuration. Which of the following representations has same configuration as this structure? In this structure, carbon is bonded to chlorine, bromine, methyl group and hydrogen. Now, we have to give the priorities based on the atomic masses. Which has highest atomic mass? The one with highest atomic mass gets the first priority. So, here bromine 1, chlorine 2nd and methyl group 3rd and hydrogen always the least priority group. As the arrow mark is moving in clockwise direction, this carbon is assigned R configuration. Okay, students? Based on the priorities, we have to give the configuration to the carbon which is a chiral carbon. A chiral carbon is the one which is bonded to 4 different groups or atoms. So, as the arrow mark is moving in clockwise direction, this carbon is given R configuration. Now, let us see the options. In the first one, bromine 1, chlorine 2nd, methyl group 3rd and hydrogen 4th priority, and the arrow mark is moving in anti-clockwise direction. So, it is given S configuration. This carbon has S configuration. Coming to the second option, bromine first priority, chlorine 2nd, methyl group 3rd and hydrogen 4th priority. Now, the arrow mark is moving in which direction? In clockwise direction. In anti-clockwise direction only it is moving. So it should be R, but there is one point which we have to remember. In this, the least priority group is lying on the horizontal line. If least priority group lies on the horizontal line, the configuration around the carbon atom will be reversed. R but S. It is S. Now, the third option, first, second, third, fourth. In this, the arrow mark is moving in anti-clockwise direction. So, it will be given S, but the least priority group is lying on the horizontal line. So, it is S but R. Coming to the fourth option, 1, 2, 3, 4. The arrow mark is moving in anti-clockwise direction, so it is given S configuration. So, in the question, the configuration around the carbon is R, and among these options, in the C option only, the configuration is R. So, option C is the correct answer for this question. Okay, students, it is a previous NEET question, students. In this is the structure of butane, N-butane. In this, C2C3 bond is rotated by 120 degrees in anti-clockwise direction. What is the conformation obtained? This is based on the conformational isomerism. In conformational isomerism, the important conformations are eclipsed, fully eclipsed and fully staggered forms. The partially eclipsed and gauge forms. So, in this, if C2C3 bond is rotated by 120 degrees in anti-clockwise direction. If this is rotated in anti-clockwise direction, what happens? This methyl group comes here. It is rotated in anti-clockwise direction by 120 degrees. When it is rotated, this methyl group comes here. So, what is the conformation? This conformation is known as gauge form. If identical groups are present with dihedral angle 60 degrees, then that form is known as gauge form. So, the answer for this question is gauge form. Okay, students, I think I have covered all the important topics in this video by taking different types of examples. Hope you like this video. Please subscribe to my channel. I am going to upload many videos useful for the entrance examinations. Thank you.